Good morning, ma'am. This is Dakshini, second BTech, CSE A section, bearing roll number 234G1A0533. My topic for CA2 assignment is sum of subsets problems. Outline of the topic. Introduction for sum of subsets problem, definitions and terminology, and there are two ways of approach. The two ways are explained in detail. Backtracking algorithm and time complexity analysis for backtracking algorithm as well as brute force approach. And next, space complexity analysis for backtracking and as well as brute force approach, and optimization techniques and the applications of the sum of subsets problems. And we will discuss real world applications later. And finally, conclusion for this topic. This is the outline of the topic. Sum of subsets problem. The main, firstly, introduction. The sum of subsets problem is a classic optimization problem in the computer science that involves finding all subsets of a given set of numbers whose sum equals to target value. The problem has many real world applications and can be solved during efficient algorithm. Introduction to the problem. First of all, we will know the problem definition. The problem definition is given a set of numbers and target sum. The goal is to find all unique subsets of the set that add up to the target sum. It is the definition of a problem. And complexity. The complexity is known to be NP complete, meaning that the time complexity of the brute force approach grows exponentially with the size of the input set. Next, we will learn applications. This problem has many applications in areas like finance, logistics, and decision making, where finding optimal combination of elements is crucial. We will learn these applications one by one later. Definitions and terminology in the sum of subsets problem. Set. A collection of unique elements is known as set. Subset. A set that is contained within another set is known as subset. Already we all know that, but just remembering those. Target sum. The desired sum of the elements in a subset. And solution set. The subset whose elements add up to the target sum is known as solution set. These are the main terminologies we used in the sum of subsets problem. It has two ways of approach. One is brute force approach and another is backtracking. First, we will learn a brief about brute force approach. It involves in three. First, we should talk about three important things in brute force approach. That is, enumerate all subsets. The brute force approach involves generating all possible subsets of the input set and checking if their sum equals to the target. Next, time complexity of this approach is the time complexity of the brute force approach is big of 2 power n, where n is the size of the input set. And the limitations of this brute force approach is this approach quickly becomes impractical for larger input sets due to the expected number is greater. Backtracking algorithm consists of three steps, that is build candidate set, check feasibility, extend or backtrack. We will know one by one. We will try to learn one by one. Generate a candidate set of elements that can be included in the current subset. Next, checking of feasibility. Evaluate if the current subset satisfies the target sum constraint. It is the second step. And move to third step, that is extend or backtrack. If the current subset is feasible, then extend it. Otherwise, backtrack to explore other possibilities. These are the three steps involved in backtracking algorithm, and it is it is the most widely used algorithm for this sum of subsets problems and n-queens problems also. Backtracking algorithm is very much widely used. Time complexity analysis for brute force approach and backtracking. We already discussed the time complexity of brute force approach is big of 2 power n, where n is the size of the input set. And for backtracking, the time complexity is big of 2 power n by 2, a significant improvement over the brute force approach. Optimization techniques. The further optimizations can reduce the time complexity even further, making the problem more tractable for larger inputs. Space complexity analysis. For space complexity, the brute force approach requires storing all 2 power n subsets leading to a space complexity of big of 2 power n. And for backtracking, the backtracking algorithm only needs to store the current subset, resulting in a space complexity of big of n, where n is the size of the input set. Optimization trade-offs. Techniques to further optimize the algorithm may involve a trade-off between time and space complexity. Optimizations and improvements they are need for sum of subsets problems is tuning, dynamic programming, branch and bound. These are the optimization techniques used for sum of subsets problems. First, we will discuss one by one in detail. Pruning. Eliminate branches of the search tree that cannot lead to feasible solution. It eliminates the branches, reducing the overall search space. It reduces the search space also. Next, we will move to dynamic programming. The memorization to store and reuse intermediate results, improving the overall time complexity. Next, we will discuss branch and bound. Compare backtracking with upper and lower bound. It eliminates to further prune the search space tree. These three are the optimization techniques used in sum of subsets problems. Real world applications. The real world applications for the brute force approach is finance, logistics, scheduling, electronics. These are the real world applications. Let us know one by one. Finance, optimal investment portfolio selection. It is the leading in nowadays. Logistics, cargo loading and packing optimization. This we all observe this in ports. Scheduling, optimal task or resource allocation. We will allocate some time for this scheduling to perform an optimal task. Electronics, printed circuit board layout design. Next, conclusion. Importance of the problem, algorithmic approaches, optimization techniques. Importance of the problem is the sum of subsets problem is a fundamental optimization problem with a wide range of practical applications. And next, algorithm approaches. Brute force and backtracking are two common approaches, with the latter being more efficient. These two are the common approaches for this sum of subsets problems and most used also. Next, optimization techniques. Advanced optimization Advanced techniques like pruning, dynamic programming, and branch and bound can further improve algorithms' performance. That's why we will use these two approaches for sum of subsets problems. And there are more about those sum of subset problems. We have less time, that's why we are not discussing here. And then this is the conclusion for my topic. And thanks for giving this golden opportunity to explain this topic. Thank you.